All right, welcome everyone, and thanks for coming to the Smarter Network panel. Even the notion of the network itself being smart is a highly disputed semantic exercise. I mean, a lot of folks believe that the beauty of the internet is how dumb it is, and that's what allows so much to be accomplished on it. And so sometimes that smart networking is used in quotes. But we're looking at ways of kind of leveraging the characteristics of the network in a better way to solve a number of different problems or create opportunities that are best solved at this sort of core level. And so we're going to discuss a number of different areas, including video streaming, which is an increasing challenge with taking up so much bandwidth, a little bit about artificial intelligence on the network and what the use of that can be. Blockchain, you've all heard the name bandied about at cocktail parties, but might not be familiar with what it is. And then we're also going to talk, a little bit about naming systems and what the role those can have in leveraging, again, the architecture of the internet. So we're going to start with Glenn Dean from Comcast Universal, and as we said in the previous session, the bios are all there for you if you want to read them. Thomas Bascom from Internet Names for Discovery and Interoperability. Tim Estelle, who's a solutions architect at BAE Systems. And finally, Rosina Tilleman-Dick is the Chief Operating Officer of the Global Blockchain Business Council. So I guess we'll just go ahead and order, since everybody's talking about something different, this won't be a heated debate, but meant to be more of an informational session, and hopefully your questions will be just about learning more about these technologies. Without further ado, I'm going to hand the talking stick to Glenn Dean. And I have this video for you whenever you want to. Okay.
So hi there, I'm Glenn Dean from Comcast NBC Universal. And I'm going to talk a little bit about hopefully bringing some hope around what we've been doing in IPv6. So for a lot of years, you've been hearing that we run out of addresses on the internet. And the IPv6 is the cure for that problem, right? We're going to go from a 32-bit address to a 120-bit address, and we're never going to run out of addresses again. And a lot of people say, well, why else would I go to IPv6? What am I going to do with it? Well, hopefully when you get done my little bit, you'll understand one thing we can do with IPv6 and one of the hopes it brings to us. So, as Jonathan said, video is a problem on the internet because there's just so much of it, and it keeps growing. We, year over year, get more than we ever had before. It's outpacing capacity in many places in the world, and we love to watch video. And there's other things emerged. We love to create videos too. We all publish them, whether it's just videos of our kids on skateboards, cats, whatever it is, all the way up through professional productions. We are flooding the internet with video. And so one of the challenges we have is, well, how do we make that continue to grow? How do we make it work really well? And how do we make use of the network the very best way possible? And so we have a small project that we've been championing within the IETF called the Glass-to-Glass Internet Ecosystem. Glass-to-glass refers to the glass of the camera, all the way through all the little intricacies to the glass of your screen. And the idea being, how can we make the network, which is what the IETF works on, how can we make it work really well with video so that the two of them can cooperate in the most efficient way possible? So Jonathan, if you can show the short video. This is a short video that sort of introduces the idea of what we're trying to get the network to do. And then I'll talk a little bit more about what you're seeing here as it rolls. So what you're seeing here is the idea that you're sitting in your home, you're watching a video, you got a screen like you have today, and you're selecting a video to play. And today that would normally go out to a CDN and pull the content back in and you'd watch it. We're trying to support that model, but in this new world, we're trying to make that CDN experience work very closely with your IPv6 network so that the actual addresses used for transporting content across the network also are merged in with the content itself. So that when I actually refer to, in this case, a movie called Big Buck Bunny, which is an open source movie, and if you work in the video industry, you get really sick of seeing Big Buck Bunny, I gotta say, because it's the one demo thing everybody uses for the demo because it's open source. But in this case, IPv6 is actually being used to directly refer to the content itself. so that instead of just being a network address, it's network address that's combined with the media so that we can use the network's own routing protocols to get you from your couch at home to the closest, best source of that content. And so what you're seeing here is literally that doing, it goes out and it gets the chunks of the movie and transfers them over one by one and using IPv6 where each chunk has a different address, and it brings it into your home and lets you to watch it. It also lets the network use its natural scaling capabilities to manage access to that content so that if the content's near, if it's already in your home, or if it's near in your network, or if it's in your neighborhood or in your state, it can get to the most efficient copy very quickly. And this makes it very nice because the content distribution then can ride on top of the network's natural routing protocols. And the two of them can work together in a very efficient way. And that's the end of the video. Let me speak a little bit about how we're going about this. So IPv6 is an open standard. It's from the IETF. And if you have, we've done this a little bit different order. I would have invited you all to come to the IETF in Prague last week, where the IETF engineers, we all got together. There were 1,300 of us last week. We got together and talked about, where are the standards going. And one of the things we talked about there was IPv6 and how to evolve it, right? We already have a pretty good deployment. I think we're up to about 30% worldwide traffic on the internet, and year over year it's growing. The hope here is that through open standards, and we're trying to bring the technology behind GG to also be an open standard, where we've already got 4 internet drafts of the ITF, so the engineers can sit back and they can comment on it. And as a group, we worldwide can come to a convergence on how to apply this concept of video and V6 working together in a very efficient way, and do it in an open source way so that everybody can get together and work on the same standard. And when we go back to the home office and start doing implementations, we can implement off a common standard, and we don't have to go through the other exercise, which is so common, where you invent it in your own companies, you do that for 10 years to deploy it, and every other company does the same thing, and then we then spend the next 10 years trying to harmonize all the different ways of doing stuff. We're trying to do this from the very ground up as an open standard through the ITF, and so I invite you to go read those drafts if you want to get really nerdy. But otherwise, that's the initial start of what GG is. It's bringing IPv6 and content together in smarter networks.
Thanks, Glenn. Quick question. I mean, how is this any different than the sort of edge caches that we hear about, Akamai and things like that? Aren't movies, when I go to Netflix and I ask for a movie, aren't there already copies that are spread all over the place so that there's one that's closer to me so that I can get to it more efficiently? What's wrong with that system that GG attempts to solve?
Actually, there's nothing wrong with that system. The system itself, in fact, GG leverages that existing infrastructure of these edge caches. But what is the problem today with a lot of the edge cache technology with the IPv4 world was that there wasn't a really great way to get the network and those edge caches to be integrated nicely together to make it use the same sort of ways to talk about content. And so that when the edge caches were developed, there were, as you would say, hacks done in the infrastructure to make them smart. So for instance, one of the classic problems when you're running edge cache is knowing where your viewer is. So if I have an edge cache that's sitting in a particular location, let's say Detroit, and I got a viewer from Detroit, because IP addresses are spread out across the world, it's very hard at times to say, oh, I know that viewer's from Detroit, I should get his content from the Detroit cache. And so, through the years, the Akamais and then the Cloudflares and everybody else operate these CDN edge caches have put information into the DNS to help sort of direct, give you a hint of where you're going. Some people view that as sort of an unnatural way of using the DNS. And so what GG does is it tries to disambiguate the need for putting that information into the DNS and more deliver at the native network level, so the network itself can know, oh, this person's here, the nearest cache is there, using the existing edge cache technology, and I can still get to them. So we've built GG to be very much entirely backwards compatible. It works with the existing edge cache infrastructure, it even works with the existing players. So we do the demos of it. We actually just use an out-of-the-box player in a tablet. Nothing's been modified. We use an out-of-the-box CDN cache. But the new thing that's been brought to the game here is that IPv6 at the network level allows us to do these very sophisticated ways of bridging the V6 world with these content caches so they can work very smartly together. So I guess the short answer is we love that model today. We're trying to make it work even better tomorrow.
Okay, I guess we'll go through and then take questions on all these things if I can do that. So, Tom, do you want to talk a little bit about that?
Great. So my emphasis has been on resource naming. That's been my passion in research for several years now. We just started recently organized a organization called Internet Names for Discovery and Interoperability. And our goal is to advance the network naming capabilities so that we can start getting meaningful names for network resources, so we can start breaking down the intermediary barriers between people and the content on the network. Jonathan, you have slides up?
Yes.
So if you think about all the types of network names that you have now, just myself, I have a whole bunch of different network names. I have my, and I'm talking about network identifiers that are so far beyond all the IP addresses and such. I have an email network name that gets me connected through email. Use the network to reach me through email, but my email network name is, very hard to find. I have my enterprise domains and IP addresses. Again, very hard to find among everything because these names are very abstract and really don't convey what I'm offering. I have phone number networks. Again, very hard to find. And I also threw in there a web num. I don't know if anybody recalls in about year 2000, VeriSign tried to give people that already had telephone numbers and cell phone numbers a web num. And so that's where you could register some meaningful number to you that you could give as a business card that gives you a unique identifier on the internet. I don't know if anybody here remembers that. But all these and the social networks are yet another network that we join and get an identifier for. But again, all these, I don't know if someone has a really unique Facebook name or identity, but that's really hard to come by. But what this has spawned is a whole bunch of intermediaries between the making of connections through the network and the individuals trying to make connections. And that gap has been filled by a whole bunch of different intermediaries. And here are some examples. The oldest intermediary is the phone book, the Yellow Pages company. They started out making paper phone books to get you connected through the telephone networks with plumbers and doctors and everybody. And that was your only way to make a network connection on the phone network was through the Yellow Pages. Now you see in your search results, they've morphed to a web service, but they still give you network connections, phone numbers, email addresses, web page addresses for the things that you want. But they're one intermediary. Search engines have become our intermediary of choice. They're the ones that resolve our happy selection of keywords to hopefully the right web address or the web content that we want. They give you the website name, the IP address of the content that you want, or the 5 sources of content you want. Social networks rely on those social networks to make the connections to the content we want. A lot of discussion in the earlier panel about how we reach content through social networks and all the suggestions that get us to the content we want. But those email addresses, the web addresses, the content that we're sharing are all coming through our social network, not through the names of the content we want. And I put a picture of Hal in there. I have no idea where we'll be talking about artificial intelligence, but I have no idea where the artificial intelligence is going to be starting to make the network connections that we seek. Next slide. So, why resource names and why now? We're at a juncture here where we're going to be seeing a whole bunch of new and different classes of information being connected to the network, and they're going to start spawning whole new classes of intermediaries. If you think about the opportunity for blockchain to start registering liens against property, that's one of the kinds of contracts I can easily see being a kind of thing we'd want from the network. How many intermediaries are going to be spawned for us to do searches for liens on properties? If I'm a general contractor and I want to do work for someone and I want to see if they've got contractor liens on their property because I know they don't pay bills, how many different intermediaries am I going to have to search for one address to find out how many different contract liens they have, or if I want to buy that property, the liens that are against the property. It's just spawning a whole new infrastructure of naming conventions and intermediaries. So why I think now we're at the juncture of either we're going to start spawning these new intermediaries, spawning these new network naming conventions, or we can start looking at converging on a naming system for resources connected to the network. Not right now we're at the domain level, where we can start working on a resource naming system that starts to converge our network requests to start getting past intermediaries and getting people to have content to put it on the network with meaningful names so that people that look for that can get to it directly. So what does that look like? Across the bottom I have a very simple example where a resource name, essentially for all the flavors of blockchain, there might be a resource name class that corresponds to all the flavors of blockchain, and then all the routing logic that lets you build a description of a new blockchain contract that gets added to the network. So it conforms and is modeled on the current naming systems where the logic builds the routing and the naming convention, and people have to come together and say, if we're going to add a blockchain contract to the network, I want to give it a name of the class and the logic that supports the retrieval of it. That is where I see we're building smarts in the network, where the network can start to respond to the kind of questions that we really need to ask, where it can start gathering data forming. We can start forming data questions. A name might not be proprietary or unique. It might be a class of things, so that 5 sources might be able to respond to a kind of network request. So you get past the one-to-one connections that we're accustomed to on a current network. And that's in a nutshell what we're doing.
Tim, go ahead.
All right, can you bring up the slide? So good segue to what I wanted to talk about. I wanted to focus on artificial intelligence, something I've been working in for the last 20 years or so. Let's go ahead to the next slide. So networks have become a lot more complex in the last couple of years, and they've reached a point where designing, creating, maintaining, and securing networks is an artificial intelligence problem. So they have become so complex that it's hard for a single individual to really understand them and to visualize them and to understand all of the implications of any minor changes on them. Let's go to the next slide. And then global corporations internally have their own networks that are also just as complex. And there's a lot that goes into running a global company. And if you've got a global corporation, you've got a global network and a global presence, you're going to see threats that are regional as well as threats that are international. So by using artificial intelligence, we can understand at a regional level what new threats are coming out, and we can apply the solutions to those to our global network so that as threats propagate across the globe, the rest of our network is already prepared for that. But then we also share that with our competitors in some cases, with our industry partners, and sharing that data across helps us all improve the overall health of the ecosystem. And a lot of that is enabled by artificial intelligence. And I thought it was interesting you said using the network to respond to the questions that we ask. I think that's, there again a situation where you're really going to need to augment that with artificial intelligence in order to really enable that. Go to the next slide. And artificial intelligence has become a lot easier. 20 years ago, it involved doing some literature search on academic resources, writing your own software in C or C++, compiling it, crossing your fingers, trying to get it all to work, and now it's become a lot easier. There are a lot of frameworks out there. You can go out to Microsoft Azure and get the machine learning virtual machine that they provide, and it's all built in there, and within a matter of minutes, you can start doing some pretty complex artificial intelligence processing on the data itself. So the barrier of entry is really lowered, and we've seen a democratization of artificial intelligence. Go on to the final slide, and that's really the point that while mid and small companies are now able to do things that only large companies or big research organizations were able to consider several years ago, we also need to understand that there's some risks there, and I suggest that we need to hold people accountable for the AI they create. So if you use all of these great resources and put something out there on the network, you need to be responsible for how it behaves on the network, and we need to hold you accountable for that.
So as a couple of you have alluded, I'm going to speak about blockchain technology today. And on Friday, one of my interns sent me an article, I think it was compiled by Washingtonian, and it listed, I think, the 15 hippest things in DC right now, and number 7 was not being able to understand blockchain. So hopefully there is some food for thought during this discussion. And before I get into the nitty-gritty of what this technology is, where it came from, and what it can do, I'm going to talk a little bit about watermelon, not just because we're the last panel before lunch, but because I think there's a lesson to be drawn from a story about 2 brothers who, to be completely candid, were not the sharpest tools in the shed, but even they could recognize an opportunity to make some money. And so one summer, when there was a really great crop of watermelon, they decided to go into business. They loaded up their truck, bought a bunch of watermelon for $1 each, and then headed to the state fair. And at the state fair, they sold their wares for $1 each. At the end of day 1, business had been really good. Almost all the watermelon were gone, and by day 2, they felt like they were really getting somewhere. But on day 3, when they started counting the money they had made, they became really deflated, because no matter how many watermelons they had sold, they just couldn't seem to get ahead. After percolating on the problem for a little while, one of the brothers looked at the other and said, "You know what? I've got it. I have the solution to our problem. We need to get a bigger truck." Too often when we're looking for solutions, we look for bigger trucks when what we actually need are smarter models. And I feel very fortunate to work with a technology that I think is one of the newer, smartest models that we have available to us. Across the globe, income disparities, growing political unrest, and economic disparity are growing. And we have never needed better, smarter solutions more. Over the next decade, it's projected that blockchain technology will redefine, replace, and upgrade a lot of the underlying systems which make our lives possible. But where did this technology come from, and what does it actually do? Blockchain actually came about during the height of the economic crisis in 2008. It was presented in the form of a white paper authored by an individual or group known as Satoshi Nakamoto. And in the last 9 years, it has become a global technology. It's the underlying technology for cryptocurrencies. So these are currencies that are not backed by governments. But the applications for blockchain extend far beyond finance. And it's still very early days, but we're already seeing use cases transform everything from insurance to governance, agriculture to logistics, medicine to media, and everything in between. And the technology relies on a couple things. Yeah, great. So we're talking about a decentralized system, which relies on decentralized computing, peer-to-peer networks, and cryptography. At its core, blockchain is a global notary. And for the purposes of this explanation, I'm going to talk about the public Bitcoin blockchain, which is the oldest blockchain in existence. Just so you understand, the code behind blockchain is open source, so anyone can build their own blockchain, but the older the blockchain and the wider the system of computers verifying the data on it, the more secure it's going to be. So I like to think of blockchain as the missing piece to the internet. Over the last 30 years, the internet has enabled us to organize the world's knowledge and information. And blockchain provides a digital mechanism for anyone with an internet connection to transfer any asset, anywhere, anytime, with unmatched security, integrity, and speed. And this is important because most assets of value are still paper. If you think of your passport or the deed to your house, these things haven't been digitized yet. And there's a reason for this. When information is moved online, it's often copied in the process. But if I want to send you the deed to a house that you just bought, it's actually really important that you get the original and that I don't keep that deed. To navigate this problem, most people rely on middlemen or intermediaries, like banks, and sometimes this works, but sometimes it doesn't, and too often intermediaries are too expensive, inefficient, and hackable. We've seen a lot of very high-profile hacks recently. With blockchain, no central authority is needed to verify transactions. The technology itself acts as the intermediary. And there's no central point of failure or attack because it's completely distributed on literally thousands of computers across the globe. So how does it work? I think of blockchain as a system of railroad tracks, and on the public Bitcoin blockchain, Bitcoin is the train that moves value from one place to another. But on other blockchains, they talk about tokens, and a token can be anything. On Ethereum, the token is Ether. And just like a train, you can put anything of value inside a Bitcoin. So if I want to send you a vote, I can put that on top of a Bitcoin. And this morning, recently Bitcoin has enjoyed a pretty dramatic increase in price. This morning it was hovering around like $2,800. But you don't need to send an entire Bitcoin to send something of value. You can cut it into as many pieces as you need. So the more established and the longer the blockchain, the wider the network verifying the information on it, and the more secure it becomes. And each asset transferred on the blockchain is recorded and packaged into a group of transactions called a block. It's cryptographically authenticated before being linked to an unchangeable chain of verified data. And the incentive structure for this is really interesting. So you need these computing data centers to verify the transactions and the computing power needed to solve the math that results in verified data is pretty remarkable. And every time these computers kind of compete with each other to solve the algorithm to verify the data, the winning node, the computer that solves it the most quickly and accurately, is rewarded in Bitcoin. So there's this built-in incentive structure to make sure that these transactions are moving accurately and efficiently, constantly. And to hack into the Bitcoin blockchain, bad actors would need to hack over 10,000 geographically distributed nodes simultaneously. So in the last almost decade of existence, the public blockchain, the underlying technology, has never been hacked. Can we go to the next slide? Next slide. That's great. So the benefits of blockchain are myriad. It provides increased security, enhanced confidence, improved auditability, and greater efficiency. And its permanence and decentralization protect from both internal and external fraud. These components allow for real-time auditability, and it's so much less expensive than the audits that we all, I don't know if we can say enjoy at our various companies, but it reduces the price dramatically. And they establish a single source of authoritative truth for institutions. On the public blockchain, you can actually download this ledger. Anyone can go online and download the ledger, but there are different permissions that you can place for kind of corporate blockchains. So why does this matter? What does it actually do? The most obvious applications for blockchain are in the financial sector, and reducing costs and complexity associated with financial transactions has the potential to open the global economy to literally billions of unbanked individuals worldwide. But some of the most compelling applications are actually beyond finance. I like the application of property rights. The challenge of securely registering property has far-reaching economic and social implications. Of the more than 7 billion people on Earth, only about 2 billion have titles that legally register their property. And the implications of this are pretty extraordinary. This so-called dead capital is worth $20 trillion. And the problem is that when ownership isn't backed by a legally binding document, it can't be used as collateral to get credit, which really stultifies economic mobility. So the value of an immutable decentralized system for recording property or whatever you need seems pretty clear, but no system, no matter how effective or efficient or secure, is worth anything if the data that you're pouring into it isn't accurate. Can we just go through a few of these?
Sure.
We're going to go down to Georgia. One more, sorry. Yeah, here we go. So the World Bank ranks the Republic of Georgia as having the third most accurate registry for property rights, which is kind of surprising. But it made it a very good theater to test a blockchain-based system for registering property. And there were a few other things factoring, I think, into their acceptance of this idea. Blockchain is probably going to be more effective in places where underlying systems aren't functioning that well. And so that made it very appealing for the Georgian government, as well as Georgia's proximity to potential political adversaries. With their new blockchain-based land registry, Georgia has secure, decentralized data with real-time auditing, and the frictions and costs associated with registering a title have been decreased dramatically. So something that used to take a couple days and several $100s now takes about 10 minutes and a couple cents. Can we go to the next slide? So Georgia is one very compelling application. Ukraine earlier this summer announced that they're moving all of their government processes onto the blockchain. And it's probably one of the most ambitious blockchain projects worldwide. They're going to have a land registry system, but they're also going to have digital notary and a lot of other applications built on top of it. This will serve Ukraine's 45 million citizens. And it's a very bold move for a country that wants to be perceived as a more transparent, corruption-free global player. Around the world, the task of restoring faith in institutions is an uphill battle. And with blockchain, we see a new way for forward-looking governments and institutions to respond to this crisis by creating more responsive and transparent citizens that work, or systems that work for everyone. Georgia and Ukraine are just two examples, but there are a lot of different countries and corporations that are looking at blockchain. Actually, Accenture and Microsoft have recently teamed up on a UN-backed project to provide digital identity to 1.1 billion people who have no form of identity worldwide. Things are moving very, very fast, and so it will likely be many years before we recognize the implications of blockchain it's still early days and things are still very young, but there's no time to spare. And I look forward to working with people like all of you to figure out what those applications are and how this technology can improve our world.
Thank you. If you had to give an elevator pitch on what blockchain is, because I think a lot of people in the room have heard the term, but just at a very fundamental level don't get what it is, what would the elevator pitch version of that be?
So to me, blockchain is a global notary, and it allows you to move assets anywhere, anytime, as long as you have a computer or an internet connection. And at the end of the day, it takes out the middleman and it empowers people to move assets peer-to-peer. It's probably one of the most significant, I think, advances since the inception of the internet.
If I might ask another follow-up question, you talk about property rights, for example. So my deed for my house ceases to be a paper document and becomes a digital document that's peer certified or notarized. What is the interaction then between that peer-to-peer based system and the governments that are giving the authority for you to own that property in the first place? What's the intersection point between those two?
It's a really good question, and it depends on the type of blockchain you're dealing with. So what we see in Ukraine is this idea of anchoring private blockchains to the public Bitcoin blockchain. So the data that's input is controlled at the end of the day by the government, and they work with a technology partner to implement all of this together. And then once the data is kind of set, it's anchored to the public blockchain. So if anything is changed after the anchoring, the network is notified. So this vast network of individuals and data centers that are securing the blockchain, they're notified. It means that it's a much more transparent system. So even if the specifics of these records aren't available for everyone, the understanding that they've been tampered with is. So if your land title is on the blockchain and somebody wants to go in and give it to their cousin because it's a really nice house, they won't be able to do that because you cannot change what has been put into the blockchain without changing every single block preceding it. And it's never been done. I don't want to say it can't be done, but it's very unrealistic that it could happen.
Thank you. Tim, when talking about artificial intelligence for the network, what do you think are the sectors that would most benefit from incorporating AI more so into the network?
I think it's really broad at this point. It's hard to imagine a sector that doesn't benefit from using artificial intelligence in some way, and I think most sectors already are. Leveraging artificial intelligence to help people to do the cognitive offload so that people can focus on the high-value tasks is something that pretty much applies to almost any sector. So I think even Sorry. So I think pretty much any sector could benefit and already is benefiting from it. We're really seeing that start to accelerate now.
And I may be the only one thinking about this, but I have a feeling people in the room, when they hear the word bot, usually have a negative connotation associated with it, of sort of distributed slave or something like that that's acting on behalf of malicious actors. So what's the distinction here? What's the in fact, in most instances, they're not even thought of as intelligent, right? So what is the difference between the good bots that you've been talking about and the bots that we read so much about?
I think in the keynote they talked about understanding the intent, and that certainly plays into that. I don't think there is a good definition. These are all very vague terms, but certainly there are a lot of bots that do provide good value. The slide that I had up earlier showed Microsoft's bot framework website, where anybody can go learn how to build their own bot that will understand intent behind text, or convert speech to text, or help you dig through all of your photos to find all the pictures of your grandmother. So there's some really amazing, helpful bot technologies that we can all take advantage of. And a lot of them are already being available through some of the major content providers as a incentive to use their service. So I think there's a lot of good that bots can do, as well as, like you said, the viruses and the negative aspects.
Tom, when I saw your long name, it made me want to run for a search engine or some sort of a natural language process or something like that. I mean, so what is the extent to which you think that these kind of expansive names are actually going to end up being part of human parlance, or are simply going to exist as a kind of alias for information that we'll get to in very different ways?
If you think about any of the network name samples that I provided, if I look at my son's Gmail address, there's no way for me to enter my son's email address because I know his name and address and such. It's just all these things are made up and assigned these network identifiers. So the purpose of a governance organization is to set up the naming logic that and have an open naming logic that lets everybody in their domain build a logic that has a meaningful name. So, for example, in the lean example I provided for blockchain contracts, the blockchain community would come together and say, we're going to have a registry, a name registry for liens, and the important things for liens are, the liened property and the parties to the lien. And those are very easy, human recognizable named constructs to build, that once I put it in the format that the name requires, I can put it on the network and be routed to the blockchain records for liens matching those facts. So yes, it can be a long logic, but those are the terms of logic required to identify the one or more things that satisfy my request for liens on a property. So, long way
and
around.
you think an average citizen is going to make use of that logic, and the logic will be sufficiently logic that it'll be intuitive to construct such a name to get the information you want?
What I think application developers are going to be able to help users build that logic. So the two steps are someone registering the name. If you go to put a domain name in or create a domain name today, you go through a logical process that says, well, right now you pick a top level domain and just see if a string of letters is available. But in a real name or resource name situation, you would go to the right logical registrar and say, I have a lien to register. And the lien registrar would say, what's this lien about? And you provide the facts, and then you say, where is that on the network? And that becomes a registered lien. The same would happen for an application developer that helps you build network requests that will search for liens. So instead of subscribing to a lien search or data aggregator, you buy an app that says for $1, I'll help you build the lien requests that go to the network and get the liens that are registered. So that's the scenario I figure for the publishing of getting a name and building a name request.
Thanks, Tom. Glenn, I'm going to press you, and I think everybody in this room, because I think the room is made up more of wonks than geeks, right? And so when you say it would be great if the underlying video streaming architecture was more tightly coupled with the network, everybody's just going to be, yeah, that's a great problem for you with your 20 patents to work on, right? But why on earth am I listening about that here? And I feel like what this audience, and this is sort of an admonition to everybody, is that we should try to be coming up with scenarios, right? That challenges we face now, and here's how it'll improve that situation or something like that. So I was thinking, Glenn, one challenge my nieces have is one of them will start watching a movie, right? And then the other one will come downstairs off the phone or something like that. Oh, so I want to watch that movie too. Please start it over again, right? And the person he says, I'm not going to start it over again. You know, you can start watching it from here. And so then the other one says, all right, I'm gonna just go watch it on my tablet upstairs or something like that. And now there's 2 copies of the movie that are streaming in, and that's part of why we have some of the congestion we have. So is that a kind of scenario that we could address with Gigi, for example?
Yeah. So in fact, we call this the SpongeBob scenario, and it's based upon a real life situation that happened to me. I have 2 kids, and they get along really well, to the point where literally one day one was sitting watching the SpongeBob movie on TV. They're streaming it. And the other one came down and said, what are you watching? Oh, I'm watching SpongeBob. And they said, oh, where are you at? Oh, I'm 20 minutes in. Well, can you start it over? And because they get along so well, the first one said no. Because they're classic kids, right? And so the response from the second one was to say, well, I could either fight the first one and say, no, you have to go back. Or in this modern age, what did they do? They walked around the room, out the room to another TV, turned it on, and started streaming SpongeBob. No problem. One's 20 minutes in advance of the other one. The real problem here, though, comes from you look at what's actually going on at the network. We're doing something stupider at that point. I have one pipe coming into my house. I've now got the same piece of content coming over it, 20 minutes time shifted, but it's the same piece of content. And now I'm making that pipe carry the same piece of content twice at the same time, and it's very inefficient. And so you run into this problem where, let's say I want to watch a very high quality movie. You know, I don't want compression. I really want to use the full capacity of my pipe. So I'm doing that. I've bought a nice pipe from my ISP. I'm watching a great movie, and then somebody in my house starts watching that same movie 20 minutes time shifted. The problem now is I've got the same chunks of data coming down, and they're sharing that pipe. And now instead of being able to use the full pipe, I have to share that pipe with my, in this case, my daughter had to share it with her brother. Where Gigi helps with that is the following way. You know, content, the people that build content standards have been evolving how content is actually delivered for over a number of years. What I'm talking about here is what we call codecs and packaging. And in the old days of the internet, when you looked at how we transmitted video, really it was just a stream of data. It started at the beginning of the movie, and it just piped byte after byte after byte, one after another, without any thought, down the pipe. And this didn't give us a lot of ability to do logic or algorithms or smarts to how we deliver that. Over time, the people that do video design created this packaging called MPEG Dash. And how MPEG Dash works is kind of clever. It actually takes the video and chops it up into little chunks between 2 seconds and 30 seconds. And so now when I get a piece of the movie, instead of getting the whole movie, I get a chunk that's either 2 seconds or 30 seconds long. What Gigi does is we take an IPv6 address and assign it to each chunk, and that's persistent. So that when I watch that chunk, it has an IPv6 address, and when Jonathan watches that same chunk, it's gonna have the same IPv6 address. This gets kind of nerdy. Usually at this point, the nerds stop me and say, wait a minute, you're about to run out of addresses. IPv6 has a lot of addresses, but you're now telling me you're gonna give a 2-second chunk of every video ever made an IPv6 address? And the answer is yes. And the answer is we did the math, and it's cool. Because not only do we have a lot of addresses in IPv6, we have a lot of addresses in IPv6. How many, basically, if you look at the internet today, we have 32 bits, gets you what, about 2 billion addresses, give or take. If I have enough addresses in IPv6 that I can give every person, not just every home, but every person on Earth today, their own internet block of addresses, the equivalent of those 2 billion addresses you have. And I will still have billions upon trillions of addresses that I've never even allocated. We can give an address to everybody in your family that's ever been alive, and we're still good. We have a lot of addresses. So video addresses this way is not a problem. But what it lets us now do is the following smart things. So Jonathan's environment can actually recognize that he's watching SpongeBob first. And when I come online with a second device in the same home, one of the potentials we can do, this is one of the dreams, is I can say, hey, I'm gonna watch SpongeBob. Does anybody else got SpongeBob? And he'll go, yeah, I'm watching SpongeBob. I say, great. So all the copies of the stuff you got coming down in, I know I've already missed the first 20 minutes, but from now on, could you keep a copy of that around for me? Or could I store it someplace so that instead of going back up to the network to get the rest of the movie after that first 20 minutes, I'll just go get the first 20 minutes I haven't got, but I'll get the rest of the stuff locally or from a near cache. And so I start making smarter use of the network. So instead of shipping the same package twice, I ship it once and reuse it twice. And this is sort of the power that IPv6 and Gigi bring together. And if you then take that to the next stage and say, well, you know, that's what I'm watching the same movie. Can I start now watching media in new ways? And can I start telling stories in new ways? This is where the power really becomes realized, because because I now have all that availability and that smarts that I can work with. I can start telling the story in non-linear formats. I can jump back and forth very efficiently. I can combine stories in an integrated way that has not been possible before, but the technology now makes possible. So all those V6 addresses let us approach content not like a single file like we've done in the past, but it lets us approach it from a bunch of collections of elements that we can reassemble and put together to tell stories in new and novel ways. Ways we haven't even dreamt of yet. And that's I get very excited about it. You can obviously see I've got very animated here when I start talking about it. I think it's really freaking cool.
So yeah, what I'm hearing from you is that this will really facilitate Mystery Science Theater being able to send their feeds separately from the movies that they're commentating on at the same time. So that'll lead to a much more efficient viewing of film criticism.
You're right. You know, and I'll just say, my other panelists here, we talked about routing, we talked about naming, and at the heart of this is what Gigi does. It is about naming and routing those segments in a very efficient way that your devices can do intelligent things with, and to create new formats for playback. So we're all we seem to be talking about different things, but in a lot of ways we're talking about the same thing up here.
Are there questions from the audience? I'm happy to take some. Great. Then let's, you here in the blue blazer with the...
Hello, my name is Avatar. I study public administration. I'm very fascinated by the blockchain technology, so my question is for Marcina. So the blockchain technology went beyond the internet, and the internet allows us to share information, not value so much without the presence of intermediaries. So will we, I'm making a hypothetical question, will we need the government at the current form? So I'm interested on the e-government and the blockchain. So how will the government change from its current form in the future, provided that there's a huge gap of trust, which the blockchain eventually will close or minimize? So how will the government change its current form, or will it ever be needed at its current form?
It's a very interesting question, and it really depends on the way governments choose to interface with the technology. There's been a lot of work, especially by IBM, over the last couple years, looking at who are the trailblazers in this space, and there are some governments which are really taking it very seriously. And I work with an organization which definitely holds that cooperation between technologists and governments is essential. We aren't advocating for some libertarian strain of blockchain leadership. We believe that governments need to work hand in hand with these new solutions. But because of the transparency which it will provide, it will change our system of government, because governments will be extremely accountable to their citizens. And just as an interesting kind of anecdote, we had a couple of large events in China earlier this year, in Beijing and Shanghai, and it was very interesting because China is far more advanced in this technology than we are in the United States, and I'm a little bit afraid that we're going to be left behind, because we had presentations from 12 government ministers and their Supreme Court justice on blockchain technology. They are planning to use blockchain in a very different way than I would hope more forward-looking governments like the United States are hoping to adopt it. But we need to be aware that, as I said, if the data going in isn't good, it doesn't really make sense to make it unchangeable and extremely secure.
Thank you. Steve Del Bianco with NetChoice, and I am a big fan of innovation that you're describing, but I make my living trying to protect that innovation from regulation. So I'd like to give 2 examples of regulations that are clash with what Tim and Tom have told you. Get your reaction to that and enlist your help to try and fight the regulation. Tom described how we could look at the liens that are filed before a contractor begins to do work on a homeowner. But that would be illegal in Europe and in any country adopting the right to be forgotten, which says that that particular homeowner may decide it's old news. And I'm not exaggerating. It was a bankruptcy, which actually happened, where a Spanish individual created the right to be forgotten as a way to say that I don't think I want people to learn that I had a bankruptcy in the past. So that clash of transparency with privacy. And then, Tim, you talked about identifying all the pictures of my grandmother. Well, 2 companies, Facebook and Shutterfly, were sued for hundreds of millions of dollars because the state of Illinois, in all their infinite wisdom, decided that you needed express written consent from an individual before you applied a facial recognition algorithm, even if it was your own grandmother. And I kid you not, and private lawyers have taken that right to the bank. So we have got to be more sober about selling the benefits of our innovation and trying to insulate and beat back over regulation.
I look at it, the network as having 2 classes of people on it. The people that have closed networks that don't want their content to be found, and they're not going to be interested in registering stuff to be found. Or they're going to, by regulation, be prevented from registering in a way that can be found. And then the open network, the people that are the slaves to the intermediaries that have content that they would love to be found, but they have no way of naming it in a way, despite search optimization and all the other things that, the roadblocks that the intermediaries and the just, massive content on the network, put in their way of being found. So I think the 2 classes of people, resource naming advancements, I think, support the people that want to be found and by statute can be found. I don't know about regulation on artificial intelligence.
Yeah, you raised a good point, and I think there's been a lot of technology over the years that has had some legal challenges as it started to really gain traction. This is not going to be an exception. It's going to be hard. There's a lot of discussion about privacy and what right we have to that and what companies can do to try and mine our data so that they can have a good business model for themselves. And unfortunately, I don't think there's easy answers, but it's going to have to play out over the next couple of years. There's a lot of interesting technologies like blockchain that are coming along that are even more disruptive. So there's people who do governance have a lot of challenges ahead of themselves. I'm a technologist. I'm excited by the options and the future that I see, but I recognize that there are a lot of legal hurdles and restrictions and First Amendment rights that really come into play in a lot of this technology, and that we can envision and build systems that are far more permissive and advanced and do more than we're willing to allow them legally.
In fairness, Steve Del Bianco is actually an interloper from a panel this afternoon that's all about the broken promises of the internet. So in theory, I think what he's doing is taking this panel from 10 years ago and critiquing what's gone on in the last 10 years. So, take it all with a grain of salt. He's the Eeyore of the room here. Who else wants to? Lori, go ahead.
Hi, I'm Lori Schulman from the International Trademark Association, and I have a wonk-generated question as opposed to a geek-generated question, although it's a geek answer, and this has nothing to do with trademarks. My question is about the slow adoption of IPv6. Not being a technical person, I had kind of always walked around thinking, well, you just add a bunch of zeros to IPv4 addresses and they go nicely into IPv6, and my understanding is not the case. And there's issues of technical translation or recoding or reprogramming in some way that is slowing this as opposed to, or are there policy reasons? So I guess I'm asking, is the slow adoption, is it more tech or policy or both?
Well, I'm not a policy wonk, so I'll declare that up front. I'm an engineer. IPv6 has an interesting history, so I'll go back a little bit. So when I first learned in my early days as an engineer, learned how to do software for networks, I had the pleasure of being taught by somebody called Richard Stevens, who he had actually literally written the book about how to do network programming. And this was, I won't give you the exact date because I don't want it on my resume of just how old I am. But it was a long time ago. He said, I'm going to teach you IPv4. But you're not going to need this for very long because IPv6 is just around the corner. And so I'll teach you v4, but you're really going to use v6. That was at least 2 decades ago. And for a long time we struggled because we didn't have a motivator, I think, to go to v6. There wasn't a forcing function. The engineers saw it. They saw we were going to run out of addresses, 20 years ago and said, we need a solution. And they came up with a solution in the ITF. But there wasn't a motivator, that forcing function to say, why do I need to switch over to it? That forcing function started happening a few years ago when we in North America could see that we literally were running out of IPv6 or IPv4 addresses. And where that really came up was in some very practical examples. If you wanted to start a new company and you wanted to set up your servers in your own data center and you wanted some address space for doing that, and you would go to the powers that be here in North America, Aaron, and say, I want address space. If I did that 20 years ago, I could get a lot of addresses. If I did it 5 years ago, I could get very few addresses. And if you do it today, you get nada. They ran out. You can buy them from somebody who's got a few to sell, but that's clearly a bad way of going about things. And so the forcing function that's really come along was we couldn't build the internet and address all the devices we have on the internet with only 32 bits of address. That gets you 2 billion devices. There are a lot more than 2 billion devices today on the internet. And so we needed something. And so we were forced by very practical realities that we have users who want devices, we have people who make devices who want to sell them, and we've got data centers that want to connect those devices and provide data to them. And so we were sort of, very prescient 20 years ago when we said we were going to run out of addresses, but now that we've actually done it, we're now seeing this change, and we've changed over. My company, Comcast, has deployed IPv6 very, very aggressively. Other companies in North America deploy IPv6 very aggressively, and have done a great job. And if you look at the traffic stats that are available, v6 is growing year after year after year after year. So I think we're in a new era that a lot of people haven't quite realized yet, that we're actually already using IPv6 quite pervasively, especially in North America. I noted that happen at my house about 2 years ago when my son, who was posting some online stuff, which tracked your post by what address did you post from, came to me one day and says, and my son's not technical, he comes to me and says, what's IPv6? And I sort of did a double take and said, why do you care? You don't write code, what do you care? He says, well, this site I posted to is posting, I used to have my stats were on this other v4 address, and now my stats are all this v6 address, and I want my quality count, my count of postings to be equal, count across both of them. And I thought, wow, when a person who doesn't do network engineering suddenly cares about IPv6, we're there, it's deployed. And I think it's really wonderful. And so, from the policy perspective, I can't comment. From an engineering perspective, we need to do it. We really need to do it. But then when I start doing things like GG, I say, well, not only once we've done it, because we needed to, what cool thing can you do with it? We start seeing stuff like GG emerge that are things we could never have done with IPv4, and there's a whole new world that we can now play in, and it's been enabled by that step forward.
Thanks, Jonathan. My name is David McCauley with VeriSign, and I have a blockchain question, and it's about the commercial acceptance of blockchain. And one indicia that I look for in commercial acceptance is insurability. And so I understand that hacking is virtually impossible, but to many people, to many consumers, hacking is really just a matter of time. So my question is the insurance industry moving into the blockchain world and insuring risks where boats and houses are put, the title is put onto a digital blockchain? Thank you.
Yeah, thanks for your question. It's a great one. And insurance companies are very interested in blockchain. We recently hosted an event during the Berkshire Hathaway annual shareholder meeting. And as a result of that event, we had Mutual of Omaha there, and we've had many meetings with them, and they are seriously considering deploying blockchain technology and a lot of interesting new applications. But The Bitfury Group, which is actually the leading full-service blockchain company, just announced a huge partnership with Risk Cooperative, which is another insurance company, and they're using blockchain to ensure remittances, especially in the developed world, as these individuals rely on that income to come to them. If something happens to the individual who is sending them, they want a mechanism to make sure that those payments can at least continue for a little while. And so there are a lot of very interesting applications with insurance and blockchain. Also smart contracts. I'm not sure if you're familiar with them, but there are really good applications there.
Sorry, this is my lovely wife, Betsy, who's running the microphone.
Thank you. Jesse Blumenthal from the Charles Cook Institute. I had a question for Glenn about IPv6 and attaching permanent identifiers to content. So, and I'll preface this by saying I am not a technical person, so I apologize if I'm butchering this. But so I understand the potential benefits of, you know, SpongeBob in a Western liberal democracy and the sort of cool things you can do in terms of better delivering content across the network. How does that play out with, let's call it, more sensitive content in non-liberal countries where attaching permanent identifiers to individual pieces of content might pose a risk? Is there a technical element I'm not seeing, or is there a privacy risk there?
No, I mean, that's a really great question. And so let me just say that there isn't one solution that works for every scenario. So and anybody that tells you there is always proven wrong in the end, I think. So, this is a great solution, I think, for a lot of environments and a lot of different scenarios for things. There's going to be scenarios where it doesn't fit. I will say, though, that this isn't an environment where everything is visible to the network. So privacy is a consideration we've taken into the design. And part of the solution there is that there really are a lot of IPv6 addresses. And so it's not crazy to say, well, you know what, I am going to assign permanent identifiers to content. But you know what, for when you're watching something, if you've said, I want to be really private, I don't want it to be seen, that, okay, great, why don't I take some addresses that are throwaway addresses, and the content I deliver to you, I'm going to use those instead of the really well-known ones, so that you get to hide in the anonymity of the trillions upon trillions, quadrillions of addresses we have. But that said, that will solve a lot of the problems. Am I going to tell you it will solve every privacy problem? No. And there may be scenarios where you go, you know what, this is very sensitive stuff, it's a very sensitive environment, maybe I don't want to do it here. It's a layer of technologies, right? We have encryption of the actual content itself today, which goes on, which is a great privacy technology. You have the anonymity of trying to use these throwaway IPv6 addresses. We have other techniques that we can employ, but even those will eventually have breaking points where maybe you really just need to have a copy in your own device that you watch. It doesn't stream over the network. It isn't a one-size-fits-all solution.
Hi, thank you. Craig Spiesel, Online Trust Alliance, Internet Society. Glenn, I want to get your insights on IPv6 a little more, because we just did an audit and we're actually seeing adoption very low. Top 1,000 consumer-facing sites, 14%. Even look at the top 100 ISPs and hosters in North America, 19%. So what are the obstacles? Is it that we need to reach, I suggest that we need to reach beyond the choir. It's not the IETF audience, we need to reach the business decision makers and technical decision makers that are to drive adoption. That's my view. I'd like to get your input on that.
Like I said, there isn't one single answer. So you're right. It's there is the part of the engineers. Even amongst the engineers, there's some debate. Some say, well, I can still do what I want to do with it before. I think that we have a constrained resource. We're out of addresses. And so over time, even if you say, well, I don't really believe that I need V6, as you start doing new things and you want to innovate, you're driven to say, well, I need more addresses. Like I said, we couldn't do what we tried to do in GG with V4. There simply aren't enough addresses to address content. There's only 2+ billion addresses. with V6, there's quadrillion addresses. That's a big jump. I mean, a lot of people don't really, it's such a huge number, we can't really get our head around it. But the forcing function really is that we have more addresses or more devices than addresses today. We're starting to talk about things like blockchains and other identifiers becoming entities. Well, how do you address an entity? You address it, right? You address it through an address. We need those extra addresses to start doing these more sophisticated ways of representing access to content or content and entities and data and whatever it is on the network. And so the adoption rates are tough to measure because sometimes you have devices that will fall back to a V4 access even when they have a V6 address assigned to them. Sometimes you have scenarios where you have devices that are running V6, but they're connecting to some gateway that's converting that access to a V4 access. And so when you look at the data, it looks like it was a V4 access, even though it really was trying to be a V6 access. So it's a complex question. But the one thing I do take heart in is that if you look at the stats, the people that are measuring this stuff, and Google has their measurements that you can go look for V6, and they're all going up. Because the trend is clear, we're not going back, we're going forward. And so while it may not happen next year that we go completely there, it's going to happen soon. And I think we're going to be talking about a new world where, we're all a V6 world, and there's some legacy V4 kicking around out there for some time to come, maybe forever, who knows. One of the problems I do think from an engineering perspective is that we have a lot of people writing code around the world now who aren't writing V6 code. They're being taught in high schools and other environments to write V4 code, and so they're going on and deploying applications which aren't V6 enabled, and then as those applications become popular and they get a wider audience, they go, oops, we got to go back and fix that. And so, from an engineering perspective, one of the things which would be nice would be to see more people like myself, when you say, oh, I've got a new project, I'm going to take, open up the toolbox, I'm going to build something. I should do that starting with V6. And not start with V4 and then migrate eventually to V6. And I think maybe that's the turning point. Eventually we'll start to see where things really kick off, where that kid out of high school who's writing the next killer app says, my killer app has to run in V6 out of the box the first time. That'll be a real turning point.
Sorry, but my question will go again around IPv6. It's an interesting topic, but I want to make it relevant to the whole panel about the smartness of the network. By the way, I'm Adiel Aplogon, very believer in IPv6. When people who use the internet, they don't care about the protocol. They want to use the internet. They don't want to know if it is V4 or V6. They want to access the internet. So my question is, how do we make the smartness of the network, which is how we develop applications, how we use the internet, how we make the internet available to people around IPv6? Is there anything like for blockchain? Is there anything specific that is being done in blockchain development that takes into consideration IPv6 as the future? Because it's only then when we will start seeing the usage of IPv6. Because many networks are developing IPv6 at the core, they are ready for that. But when we start measuring the usability of the IPv6, then we see a disconnect. So how the application side, the SmartNet side of the network is taking IPv6 into consideration for us.
So just if I understand your question correctly, you want to know if blockchain technologists are taking into account this. Yeah, I mean, and it totally depends because there's so many people working on blockchain-based solutions. So it really depends on what company you're working with. And there are a lot of people that aren't tied to formal companies. But I totally agree that it's a very important development to be aware of. And that's why organizations like the Global Blockchain Business Council are working towards standards in this space to make sure that there are some international guidelines that make sure that the technology is deployed responsibly.
And if I can sort of put a plug in for the standards, the IETF is the organization that developed IPv6. It's the organization that developed all the core protocols the internet runs on. And one of the great things about that is that it's open. Yeah, and so, I think what we'll see over time is more people coming to the ITF, participating in the ITF meetings. And we're seeing this actually, that are, building applications around IPv6 and building devices around IPv6. And they get to the point where they go, okay, great, I need to come because I want this small change. I've invented a better mousetrap, or I've invented the better bread slicer, but it needs something very particular because of IPv6. I need this little change the network made. And that's where it's a great opportunity because people come to the ITF and they say, I've got a better mousetrap and it runs on IPv6, but I need this tiny little change made. And so, this room is primarily full of policy wonks. We have other rooms full of technical nerds, and we all work together sort of on these common goals. And so I will put a bit of a plug in for my favorite organization, the ITF, and send people there, participate, join. The organization is very strong, but there's always room for more people in the room and more needs. So come join us. We're going to meet next in Singapore in the fall.
If I could take a whack at it, I look at IPv6 as driving faster, better, cheaper transport of content on the network. And the people that are paying for that transport are the end users and the customers. I don't see the app guys being incentivized really to make my content move faster than I'm getting. So it's going to be the people that are buying the big bandwidths that are looking for the apps and the applications and the technologies that, let them use IPv6 to move stuff faster, better, cheaper. So that's going to be the carriers, big NBC Universal content providers and such. I think that's my 2 cents.
And if I could chime in as well, I think the biggest challenge with IPv6 is it is a big cultural change, and cultural change is always hard. And it's not just a larger address space. There's differences in how data gets routed. There's differences in how you build security into your network. If I design from the ground up a IPv4 network versus an IPv6 network, the security stack would look very different in the way I set that up. So there's an education challenge as well, where we have to, like you said, go back and teach the young engineers who are just learning about computers IPv6 first, so they can realize the advantages that IPv6 can offer them and take advantage of them. Because right now you have a bunch of people who come from my generation who learned IPv4, and it's a leap for them to take advantage of the IPv6 features. We naturally fall back on what we're comfortable with, and that's part of the cultural challenge.
We have a remote. Down here.
Oh, thank you. Ann Rakuya, Robbins World Knowledge Bank. And I'm question, kind of a follow-up on the risk question in blockchain. So are remedies dependent on smart contracts, or is there any crosstalk between the blockchain and consequences of breaking it? I don't quite see that. Did you understand my question?
I'm not sure I got the gist of what you were asking.
Well, you said that as a disincentive, that if it's broken, you will know, all the rest of the contributors or participants in the chain will know. But does that lead to something else? Are there remedies that are built in, or is that all dependent on the smart contracts or insurance or some other mechanism?
So it's a good question, and blockchain, no matter how many people are using it as a buzzword right now, it's not a panacea. It's not perfect, and no technology is. But it does mean that when changes are made to a system that shouldn't be made, the probability of them getting caught is much greater. And then the opportunity for recourse is pretty clear. If you identify that and the network, which operates on a consensus model, agrees that that change shouldn't have happened, then whatever recourse needs to be taken can be made fairly easily. And it can change, depending on who the contributors to the network are. Smart contracts are a little bit different because they're written in computer code. So it's less of a consensus model and more of just kind of self-executing contracts. But there is potential for recourse, and that's one of the reasons why it's so important.
Well, I think we're just about out of time. Obviously, these were like very big topics that we're not going to get too in-depth into in an hour and a half, but thanks for coming and being part of the session. Hopefully there's some buzzwords now in your head that you can associate with scenarios when they come up in the future and get more information. Please join me in thanking our esteemed panel for sharing their knowledge. And enjoy your lunch.